This is the EdExcel GCSE 91 Maths Foundation Paper 2, which is a calculator paper and it's from the sample papers. Question number 1, we have to write down the value of the 3 in the number 4,376. Well, we've got thousands, hundreds, tens and units. We have 4,000, 3 hundreds, 7 tens and 6 units, and therefore the value of the 3 is 300. Question number 2, we have to write 7/16 as a decimal. If I type in 7/16 into my calculator and then press STD, we can see the decimal equivalent is 0.4375. Question number 3, here is a list of numbers. From the numbers in the list we have to write down a cube number. Well, possible numbers we could have 27 and 64. These are examples of cube numbers, so I'm going to write down the 27. Question number 4, we have to find the value of 2.8 subtract 0.45 all squared plus the cube root of 5.832. Let's type in this into our calculator. Open bracket. We've got 2.8 subtract 0.45 close bracket. Then we want to square this and then we add on the cube root, so we press shift and then the square root button on this particular calculator. Then we've got 5.832, and if I press STD it turns out we get 7.3225. Question number 5, there are some boys and girls in a classroom. The probability of picking at random a boy is a third. What's the probability of picking a girl? Well, the probability of picking a girl is equal to 1 subtract 1/3, which is equal to 2/3. So we end up with 2/3. Question number 6. John writes down 1 multiple of 9 and 2 different factors of 40. John adds together her 3 numbers. The answer is greater than 20 but less than 30. We have to find 3 numbers that John could have written down. Well, if we write down the multiples of 9, we've got 9, 18, 27, 36, 45, so on and so forth. For the factors of 40, we've got 1 times by 40, 2 times by 20, 4 times by 10, and 5 times by 8. Now, what we have is 1 multiple of 9 being added to 2 different factors of 40. Now, if I add together the 18 and the 1 and the 2, well, we have 18 plus 1 plus 2, so the 18 is a multiple of 9, 1 is a factor of 40, 2 is a factor of 40, we get a result of 21. 21 is greater than 20 but less than 30, so the 3 numbers we could have written 1, 2, 18. Question number 7. ABCD is a square. This diagram is drawn accurately. What fraction of the square ABCD is shaded? Well, we've got this section, which is a half of the length AB, and this side, which is half of AD. And so the area of this particular bit will be 1/4 of the entire square. And we've got that repeated 3 times, as we see here. Now, this bit over here will be 1/4 of this area here, which is 1/4. And that's 1/16. And this area here is a quarter of this area. So 1/4 of 16th is 1/64. And so therefore, the fraction of the entire square that's shaded, well, what we have is 1/4 plus another 1/4 plus another 1/4, and then we add on 1/16, and then we add on 1/64. So let's work all of this out. We've got 1/4 times by 3 plus 1/16 plus 1/64. And it turns out we would get 53 out of 64. So we have 53 out of 64. Question number 8. Sam and Max work in a shop from Monday to Friday. Sam draws a graph to show the number of TVs each sell. And we have to write down 3 things that are wrong with this graph. Well, we don't know what the grey bar represents or what the black bar represents. So there's no key. That's the first thing that's wrong. And if we take a look at the vertical scale, we've got 0, 1, 2, 3, 5, 6, 7, 8, 9. So the next thing we can spot is 4 is missing from the scale. And the third thing that's wrong is there is no label for this y-axis. Question number 9. Here is a list of 12 numbers, and what we have to do is find the median. Well, what we need to do is put the numbers in order of size to begin with. So we've got the 11, which is the smallest, followed by the 12, and then this 12, and then this 12, so we've got 3 12s. Then we've got the 13, then we've got these 2 15s, and then we've got this 17, and then we've got this 19. So now we can easily find the middle number. Now if we cross off from either end, as we are doing now, then what we can see is that 13 will be the median. Question number 10 for part A. Rob buys P packets of plain crisps and C packets of cheese crisps. We have to write down an expression for the total number of packets of crisps Rob buys. Well, we've got P plus C as our expression. For part B, we have to solve 3x minus 5 equals 9. First thing we can do is add 5 to both sides, leaving us with 3x equals 14. And now if we divide both sides by 3, what we will be left with is x equals 14 over 3. So we have x equals 14 over 3. Question number 11. Adam says when you multiply an even number by an odd number, the answer is always an odd number. For part A, we have to write an example to show Adam is wrong. Well, if we have something like 2 times by 3, which is 6, we've got 2, which is an even number, 3, which is an odd number, and we can see the result is 6, and therefore, because 6 is even, Adam is wrong. And for the next part, Betty says when you multiply 2 prime numbers together, the answer is always an odd number. Betty is wrong, we have to explain why. Well, 2 is the only even prime number, and if we multiply any integer, whether it's prime or not prime, we are multiplying this integer by 2, and the result will be even, not odd, which means Betty is wrong. Question number 12. You can use this information in the table to convert between kilometers and miles. We've got 0 miles is 0 kilometers, 5 miles is 8 kilometers, 20 miles is 32 kilometers, and 40 miles is 64 kilometers. We have to use this information to draw a conversion graph. Well, let's plot those points we've got. Well, what we need to do is add on the vertical scale. And what we can do is go up in tens. So here we can see our vertical scale. So now if we plot the points, we've got 0, 0. We've got 5, 8. So 5 across 8 up is over here. Then we've got 20, 32. So 20, 32 is here. And then we've got 40, 64, which is here. And now what we need to do is join those up with a straight line. So if we do that, we would have something looking like this. And then for part B of the question, which is further 20 kilometers or 15 miles, you must show how you get your answer. Well, first of all, we can convert the 15 miles to kilometers. So if I do that, I draw a line up and then across. And what we can see then is 15 miles is the same as 24 kilometers. So which is further, the 15 miles, which is the same as 24 kilometers, or the 20 kilometers? Well, we can see that 15 miles is further than 20 kilometers. Question number 13. We've got ABE and CBD, which are straight lines, and we have to show that the triangle ABC is an isosceles triangle. Give a reason for each stage if you're working. Well, first of all, we can find out what this angle here is. This angle here is the same as this angle here, which is 80 degrees. So the angle ABC is equal to 80 degrees, and the reason for that, vertically opposite angles are equal. We can now find out what this angle here is. Well, that angle, ACB, that's equal to 180, subtract the 50 degrees, subtract the 80 degrees here, and it turns out the angle ACB is 50 degrees. So this angle here is 50 degrees. The reason for that is because angles in a triangle sum to 180 degrees. And therefore what we can see is we've got the angle CAB, which is equal to the angle ACB, which is 50 degrees. So we've got two angles which are equal in this triangle, and therefore we have an isosceles triangle. Question number 14. The diagram shows a tank in the shape of a cuboid. It also shows a container in the shape of a cuboid. The tank is full of oil. The container is empty. 35% of the oil from the tank is spilled. The rest of the oil from the tank is put into the container. We have to work out the height of the oil in the container. Give your answer to an appropriate degree of accuracy. So, first thing we can do is find out the volume of the tank. That will equal 60 multiplied by 50 multiplied by 40, which is equal to 120,000 centimeters cubed. Now we are told that 35% of the oil from the tank is spilled, and this means 65% is left over. So what we need to do is work out 65% of the 120,000. So I've got 0.65 times by 120,000, and it turns out we get 78,000 centimeters cubed of oil left over. So the rest of this oil is put into this container. So what's happening is we've got the oil over here, which is being put back into the container. As we see here. And what our job is to find out this height here, h. So to work out that height, what we have is 80 times by 70 multiplied by h, which is equal to 78,000. Now we need to find out what h is. So h is equal to 78,000 divided by 80 times by 70. So we've got 78,000 divided by 80 times by 70, and it turns out we get 13.928 etc. centimeters. So to an appropriate degree of accuracy, let's round it to the nearest whole number. We get a value of around 14 centimeters for H. Question number 15. The diagram below represents two towns on a map. We've got a scale, 1 centimeter represents 3 kilometers. We have to work out the distance in kilometers between town A and Moseley. Well, if I measure this distance here, what we can see is we've got 7.5 centimeters. So, what we know from the question is 1 centimeter would represent 3 kilometers. Now, what we have is 7.5 centimeters. So if I multiply through by 7.5, 3 times by 7.5 is 22.5 kilometers. So we have 22.5 kilometers. Question number 16, we have to find the highest common factor of 24 and 60. Well, if I think about this 24, let's rewrite it in its prime factors. We've got two numbers which multiply to give 24, so we could have the 2 and the 12. The 2 and the 12, well, the 12 we can split up as 3 times by 4, and the 4 we can split up as 2 times by 2. For the 60, we've got 2 multiplied by 30. The 30 we can rewrite as 2 times by 15, and the 15 we can write as 3 times by 5. So therefore, for the highest common factor, let's see what's common to each. We've got the 2, which is common to both. We've got the 3 here, which is common. And we've got this 2 and this 2, which is common. And then we multiply these together. So the highest common factor is 12. Question number 17. Soap powder is sold in 3 sizes of box. We've got 2 kilogram box, 189, 5 kilogram box, 430, 9 kilogram box, 846. And we have to find out which box of soap powder is the best value for money. You must show how you get your answer. Well, what we can do is find out how much it costs per kilogram. So if we take a look at the 2 kilogram box, 189 divided by 2, we get 0.945 per box, rather 0.949 per kilogram. And if we take a look at the 5 kilogram box, we've got 430 divided by 5, which is equal to 0.86 per kilogram. And if we take a look at the 9 kilogram box, we've got 846 divided by 9, which is 0.94 per kilogram. So which one has the best value for money? Well, because this is the cheapest what we can say then is the 5 kilogram box has the best value for money. Question number 18. F is equal to 5x plus 2y, x is 3 and y is minus 2. We have to find the value of f. Well, we would have f equaling 5 multiplied by 3 plus 2 multiplied by minus 2. So if we know that x is if x is 3 and we know that y is 2, but the y is minus 2, we substitute these in, and if we work this out, we get 15 minus 4, which is 11. So f is 11. Question number 19. Jane made some almond biscuits which she sold at a feet. She had 5 kilograms of flour, 3 kilograms of butter, 2.5 kilograms of icing sugar and 320 grams of almonds, and we've got a list of ingredients for making 24 almond biscuits. We require 150 grams of flour, 100 grams of butter, 75 grams of icing sugar and 10 grams of almonds. Jane made as many almond biscuits as she could using the ingredients she had, and we have to work out how many almond biscuits she made. Well, what we need to do is think about how many batches of this 24 we can make given these ingredients. So, if I think about the flour, well, I've got 5 kilograms of 5,000 grams available, and for 24 almond biscuits I need 150 grams of flour. So if I divide this amount by 150, then what we end up with is 33.3 recurring. So this is how many batches of 24 we can make. And therefore, what I need to do is multiply this 33.3 recurring by 24, and it turns out I get 800. So if I just think about how much flour I have, I can actually make 800 biscuits. Now, if we think about butter, then with butter, I've got 3,000 grams of butter available, and if I divide this by 100, what we will get is 30. So what I can make with butter is 30 batches of this 24. So the total number of biscuits I can make then will be 30 multiplied by the 24, which is 720. So I'm restricted now to make 720 biscuits because I do not have enough butter. I've got plenty of flour, but I don't have enough butter. Now we can think about how much biscuits we can make given the amount of sugar we have. Now with sugar, we've got 2.5 kilograms or 2,500 grams, and if I divide this by 75, then what I will end up with is 33.3 etc. So I can make 33.3 etc. batches of 24 biscuits, and then if I do 33.3 recurring multiplied by 24, I get 800. So still I'm restricted by the amount of butter. I can only still make 720. Now let's think about the almonds. With almonds, I've got 320 grams available, And if I divide this by 10, that tells me I've got 32 batches I can make. And therefore, if I do 32 times by 24, I get 768. So what I'm restricted by is the amount of butter I have. And therefore, the greatest number of biscuits we can make then is 720. So she can make 720 grams of biscuits. Question number 20. We have to factorise for part A 3f plus 9. Well, the highest common factor of 3 and the 9 is 3. So 3 is our highest common factor, and inside the bracket we would have f, because 3 times f is 3f, and then we add on 3, because 3 times 3 is 9. Next we have to factorise x squared minus 2x minus 15. Well, what we are looking for here are two numbers which multiply to give minus 15, and which add to give minus 2. You will find these two numbers to be minus 5 and 3. Minus 5 times 3 is minus 15, minus 5 plus 3 is minus 2. So when we come to factorise, we would have x minus 5 multiplied by x plus 3. So I've got x minus 5 times x plus 3. Question number 21, we've got q equals p divided by r plus s, and we have to make p the subject of the formula. So if I begin with q equals p divided by r plus s, the first thing I can do is subtract s from both sides. And if I do that, I would have q minus s equals p divided by r. And now if I multiply both sides by r, then this and this would cancel, leaving me with p equals r multiplied by q minus s. So we've got p equals r multiplied by q minus s. Question number 22. A tin of varnish costs £15. A rectangular floor has dimensions 6 meters by 11 meters. The floor is going to be covered in varnish. Helen assumes that each tin of this varnish covers an area of 12 meters squared. Using Helen's assumption, we have to work out the cost of buying the varnish for this floor. For the area of the floor, we've got 6 times by 11, which is 66 meters squared. Now we can find out the number of tins we require by working out 66 divided by 12. And it turns out we get 5.5. So therefore, we would require 6 tins. Now, if each tin costs £15, the total cost will be 6 multiplied by 15, which is 90. So it costs £90. Now, Helen finds that each tin of varnish covers less than 12 meters squared. We have to explain how this might affect the number of tins she needs to buy. Well, if it covers less area, what we would have to do is buy more tins. Question number 23. Frank, Mary and Seth shared some sweets in the ratio of 45:7. Seth got 18 more sweets than Frank. We have to work out the total number of sweets they shared. Well, here is a bar model to represent this ratio. We've got 4:5:7. And we are told that Seth got 18 more sweets than Frank, which means that this difference between Frank and Seth is 18. So if we have 18 split up into 3 parts, each part will be worth 6, as we see here. So we've got 6 for each part. So with this we can find out the total number for Frank, Mary and Seth. Well, for Seth we would have 1, 2, 3, 4, 5, 6, 7 times by 6, which is 42. For Mary we would have 5 times by 6, which is 30. And for Frank, 4 times by 6, which is 24. And therefore, the total, 24 plus 30 plus 42, is 96. So the total number of sweets they shared is 96. Question number 24. We have PQR, which is a right-angled triangle, and we have to work out the size of the angle marked X to 1 decimal place. Well, we've got the opposite and the hypotenuse, what connects us as sine. So we have sine X equals 5 over 14. X then is equal to the inverse sine of 5 over 14, and if we work this out, we would get 20.92 etc. degrees. So to 1 decimal place we've got 20.9. Question number 25. Here are the first 4 terms of an arithmetic sequence. For part A, we have to write an expression for the nth term of this sequence. Well, the first thing we can do is find out the difference between each of these terms. The difference between each of these terms is plus 4. And the inverse operation of adding 4 will be to subtract 4. So if I do 6 subtract 4, that will be 2. So my nth term will be 4n plus 2. Next, the nth term of a different arithmetic sequence is 3n plus 5 is 108. A part of the sequence. Show how you get your answer. Well, if I set the 3n plus 5 equal to 108, then I can see that 3n is equal to 103, and if I divide both sides by 3, we can see n is equal to 103 divided by 3, which is not a whole number. So 108 is not a part of this sequence. Question number 26. Axel and Lethner are driving along a motorway. They see a road sign. The road sign shows the distance to junction 8. It also shows the average time drivers take to get to junction 8. The speed limit on the motorway is 70 miles per hour. Lethner says we will have to drive faster than the speed limit to drive 36 miles in 26 minutes. Is Lethner right? You must show how you get your answer. Well, to junction 8 it's 30 miles and it will take approximately 26 minutes. Now here we've got miles per hour. So what we can do is convert the minutes into hours. And to do this we would have to divide by 60, and also hours to minutes we times by 60, which means that the 26 minutes, if I divide that by 60, well, we get 0.43 recurring hours. So with this we can find out the average speed. For the average speed, we've got the distance, which is 30 miles, and then we divide this by the time, 0.43 recurring hours. So if I do 30 divided by this, I get a value of 69.23 etc. miles per hour. And this value here is less than the 70 miles per hour, which means she's going under the speed limit, so she does not need to drive faster, and therefore she is incorrect. Question number 27. The table shows some information about the foot lengths of 40 adults. For part A, we have to write down the modal class interval. Well, mode means most common. The most common is the one with the highest frequency, which is 12, and that would correspond to this interval here. We've got 22, which is less than or equal to f, which is less than 24. Then for part B, we have to calculate an estimate for the mean foot length. Well, first of all, we need to find the midpoint of each of these. We've got 17, 19, 21, 23, 25. Now we need to work out the frequency times the midpoint. 17 times 3 is 51. 19 times 6 is 114. 21 times 10 is 210. 23 times 12 is 276. 25 times 9 is 225. Now if I add up all the number of adults, I would get 40, and if I add up all of this, well, we would have 51 plus 114 plus 210 plus 276 plus 225, which is 876. So the mean, that will equal 876 divided by 40, which is 21.9. Question number 28. Triangles ABD and BCD are right-angled triangles. What we have to do is work out the value of x. Well, let's focus on the triangle ABD. If we use Pythagoras, then we have BD squared plus 5 squared equals 10 squared. So BD squared will equal 10 squared subtract 5 squared, which is 75. Which means BD is equal to the square root of this, which is 5 times by the square root of 3. So this length here is 5 root 3 centimeters. Now we can find out x using, again, Pythagoras. If we concentrate on the triangle BCD, then using Pythagoras we would have the 5 root 3 squared plus the 4 squared, which is x squared. So if I've got 5 root 3, then square it and then add on 4, I get 79 equals x squared, and if I square root, I would have x, which is the square root of 79. As a decimal, we can see x is equal to 8.88, etc. So to 2 decimal. So let's just double check this. We've got 75 plus 16. Rather, here we get 91. So the square root of 91 is 9.539, etc. So to 2 decimal places, we get 9.54 centimeters to 2 decimal places. Question number 29. Here is a probability tree diagram. We have to work out the probability of winning both games. So we win game A, then we win game B, and that will tell us the probability of winning both games. So the probability of winning both games, we would have 0.2 multiplied by the 0.3, which is equal to 0.06.